Good evening, dear students. Today we are going to see the catalysis in surface chemistry. In 12th surface chemistry lesson, now we are going to see about the catalysis. For example, if you take A plus B, these two are reactant. These two reactant gives a product P. Okay, it gives a product. Let us assume this. Now, the reaction carried out, you put a catalyst. This is called a catalyst. When you add a catalyst, the reaction it may alter the reaction. Catalyst may be alter the reaction. And those days at first, all the catalysts, they thought that they are enhancing the rate of the reaction. They are enhancing the rate of the reaction. But later they come to know it can retard the rate of the reaction also. In both ways, it can speed up the rate of the reaction, it can decrease the speed of the rate of the reaction. So now we are in the position to define what is the catalyst. Okay. The amount of substance which alter the rate of the reaction. The amount of substance which alter the rate of the reaction is called a catalyst. Because we cannot say always enhance the substance, enhance the rate of the reaction, it's called a catalyst, or always we cannot say the substance which retard the rate of the reaction, we cannot say that is a catalyst. So, all over, the definition for the catalyst is given by the substance which alter the rate of the reaction. Alter means we can increases or decreases the rate of the reaction. Okay. So, this is called catalyst. The substance which added to the main reaction, whether when a reactants are involved in the reaction, when you added some substance, then the rate of the reaction is altered. Those substance is called a catalyst. Very important thing is, it should not involve in the chemical process inside. It should not alter the product formation. Okay. So after the reaction is completed, the catalyst should come out. The catalyst should come out of the reaction. So without involving the main reaction, it altering the rate of the reaction, those substances are called a catalyst. Okay. Then the process is called or the phenomenon, by using some substance, we are altering the rate of the reaction. Those processes called a catalysis. Those processes are called a catalysis. Catalysis. The substance which we used is called a catalyst. The process is called a catalysis. Okay. Now it's clear what is called catalysis. Catalysis is nothing but we are adding some substance for the reaction. It alters the rate of the reaction. Those substance is called a catalyst. The process is called a catalysis. Okay. The process is called a catalysis. So let us see different type of catalysis. There are many types of catalysis. First we can see homogeneous catalysis and heterogeneous catalysis. Homogeneous catalysis and heterogeneous catalysis. Okay, what is called a homogeneous catalysis? That we are going to see now. So in a reaction, in a chemical reaction, these are the three components. One is a reactant, another one is a product, another one is a catalyst. Okay. These are three main components. RPC. Reactant, product, catalyst. Okay. What is called homogeneous catalysis? Homogeneous catalysis is nothing but all three are in the same space. All three are in the same space. Then they are called as a homogeneous, because if you take a liquid, all those three are liquid. If you take all those three are gases, all those three are gases. That is called the same phase. Then the catalysis process is called a homogeneous catalysis. Let us see a few examples for a homogeneous catalysis. sulfur dioxide with oxygen, it gives in the presence of NO. So catalyst always mentioned like this, NO, within the bracket in order to differentiate the reactant. Most of the catalysts written on the arrow mark of the equation, or otherwise within the bracket we can mention that is a catalyst. What is going to happen? To SO3. Okay, to SO3 plus NO. After the reaction is completed, the catalyst should come out. Okay. So this is called homogeneous catalysis. Why sir it is called as a homogeneous catalysis? That's your question. Okay. What is the homogeneous catalysis? The reactant, product, catalyst all are the same phase. For example, here SO2 is a gas, O2 is also a gas, NO catalyst they are also gases, here product also gases. So everything in the same phase. It may be a gases or liquid. Here the formation of sulfur dioxide from sulfur dioxide, SO2 gas, O2, these two are reactant. These two are reactant. Whereas NO is a catalyst. NO is a catalyst. Then you are getting sulfur dioxide is a gas. So all are in the form of gases, same. So that is, they are given as a homogeneous catalysis. Likewise, you can have a dissociation of acetaldehyde. Ionic catalyst in the form of vapors. Okay, that is going to CH plus remaining order CH for methane is formed again carbon monoxide. So the dissociation of acetaldehyde in the presence of iodine vapor, you are getting methane and a carbon monoxide. See here, acetaldehyde in the vapor form, iodine in the vapor form, and methane and carbon monoxide all are in the vapor state. So vapor phase, you are dissociation of acetaldehyde, it gives a methane and a carbon monoxide in the presence of catalyst iodine. Iodine also in the vapor form. Then we can have an equation like this. Ester hydrolysis or ester is treated with the water in the presence of sulfuric acid, H2, so for sulfuric acid, we are getting it as CH3 acid plus alcohol. Acid plus alcohol. See, all are in the aqueous form. Aqueous form. These two are reactant. These two in the aqueous form. Acid, sulfuric acid in the also aqueous form. You are getting acetic acid in the aqueous. So this also can be said as a homogeneous catalysis because reactant, these two are reactant, catalyst sulfuric acid, product all are in a aqueous form. Above we have seen the gaseous form, here we are seeing that aqueous form. Likewise you can have many examples to see the homogeneous catalysis. So now it's clear what is called a homogeneous catalysis. In a catalytic process, all are reactant, product, catalyst. All those three are in the same phase. Then that is called a homogeneous catalysis. Now you can define the heterogeneous catalysis. All those R, P, C. All those three are in a different phase. Are in a different phase. Same phase homogeneous, all are in a different phase. Among the three, any one of these different state, physical nature is changed, then that is called a heterogeneous catalysis. That is called a heterogeneous catalysis. Okay, let us see the example for heterogeneous catalysis. Same sulfur dioxide plus oxygen. Now I am changing the catalyst. Vanadium pentoxide, V2O5 or platinum. It will give a SO3. See, SO2 gas, O2 gas, and platinum is a solid. See how they differ. Sir, you are writing same reaction. It is not same reaction. It is entirely differ. But process is same. Sulfur dioxide to sulfur dioxide. The same. But what is changed here? The catalyst is varying. On homogeneous catalyst, the same reaction I have written. Everything in a gaseous form. Everything in a gaseous form. But now, if you see SO2 gas, O2 gas, but platinum or vanadium pentoxide in the form of solid catalyst is used. So this is called a heterogeneous catalysis. Okay. Then one more example we can have it ammonia, Haber process. To NH3 in the presence of iron. Iron is a catalyst. You know very well iron solid. These two are gases. So this is another one example for a heterogeneous catalyst. Likewise, we can write more. See, hydrogenation of alkene in the presence of nickel. Nickel catalyst, if we use it, we are getting methane. Then you may write this equation: oxidation of ammonia. Oxidation of ammonia in the presence of platinum. You are getting that. Okay. This is also heterogeneous. These are the heterogeneous catalysis. Till you want more example, it may go like this. Decomposition of peroxide. Decomposition of peroxide in the presence of platinum. Platinum solid catalyst. You are getting the H2O, O2. Okay, it's not balanced with 2 here. 2 will be balanced. This is also heterogeneous catalysis. Till more example you want, you can have it benzene. Acylation of benzene. This is benzene treated with acetyl chloride, CH3CuCl. The catalyst, these two are reacted. What is the catalyst? Anhydrous aluminum chloride is used as a catalyst. Anhydrous. So you are getting that acetophenone. These 6 examples for the heterogeneous catalysis. These 6 examples for the heterogeneous catalysis. So dear student, now we have seen the what is called homogeneous catalysis, what is called heterogeneous catalysis. All reactant, product, catalyst are in the same phase, they are called homogeneous catalysis. For example, we can have these 3 examples we have seen already. Now in the same way, what is called heterogeneous catalysis? In a catalysis process, if any one of the reactant or product or a catalyst in a different phase or all are different, then it is called a heterogeneous catalysis. Now it's clear with the examples we have seen. So now you are clear with the homogeneous catalysis and heterogeneous catalysis. Let us see the characteristic of catalyst now. Let us see the characteristic of catalysis. First one, the good catalyst should have small quantity. Small amount should be taken. If the process may be liter and liters, you need to have a pinch of catalyst should be used. The amount of catalyst should be very minimum. That is the quality, first and best quality of the catalyst. For we are all for tower of biryani, we are adding a pinch of salt. Okay, or a pinch of salt is called there. Even for such a large amount of rice or curry, we are adding a small amount of salt. Okay, the salt makes the taste. Likewise, here in a chemical reaction, the catalyst should be very small in quantity. That is the first ever quality of the catalyst. Then there is no chemical change of the catalyst. There may be slight physical change may be happen to the catalyst. The catalyst should the chemical composition of catalyst should not be changed. When the reaction is completed, it should come out as such. Okay. So there should not be any chemical changes in a catalyst. Okay. If the reaction carried out, you are adding a catalyst. The physical formation, there may be some changes. Physical changes, there is a possibility. It is allowed for the catalyst. But catalyst should not undergo the chemical change. And third one, specific unit action. What is called specific in action? So, if you take a, for example, we take a platinum for a sulfur dioxide preparation. Okay, manufacture of sulfur dioxide, we are using a vanadium pentoxide or platinum. These two cannot be used for the synthesis of ammonia. Okay, for particular reaction, you should have a particular catalyst. That is called specific in action. Okay, the catalyst should have a specific in action. So we cannot use or interchange the catalyst. If the catalyst made for a particular reaction, that should be used for the particular reaction. The same catalyst cannot be used for a other reaction. That is called a specific in its action. Then does not disturb the equilibrium. Does not disturb the equilibrium. So when you add a catalyst, what happens to the reaction? A plus B, equilibrium C and D. If you add a catalyst, the catalyst what is doing that? The catalyst can alter the timing to reach the equilibrium. It can reduce the or enhance the time taken to reach the equilibrium, but it should not disturb the equilibrium and a equilibrium constant. It should not disturb the equilibrium and a equilibrium constant. That means the catalyst should not affect the equilibrium. That is the thing is there. The catalyst should not affect the equilibrium. And then optimum temperature. Optimum temperature. What is called optimum temperature? In a particular temperature, while you are adding the catalyst, you will get a more product. Okay? Or the reaction carried out very fast as you wish it. Then that temperature is called optimum temperature. For example, in a Haber process synthesis of ammonia, it need a particular temperature range. That temperature range only you can get a product. Always you cannot get a, if you added, the catalyst is added, the reaction is carried out, you cannot expect more product. But that optimum range for each and every reaction, they are having the certain particular range of temperature. On those temperature, you may have a more amount of product. That is called the maximum amount of product when the temperature, what temperature the maximum amount of product is obtained. That temperature is called the optimum temperature. Okay. In a equilibrium, the optimum temperature is must. Then only the product, the yield will be more. You want to have a more yield, you should maintain the optimum temperature and pressure. So the catalyst, the optimum temperature should be noted in a characteristic of catalyst. Then does not change the nature of the product. Nature of the product. Does not change the nature of the product. So what is formed, whatever may be, if you are taking a catalyst or not, A plus B gives C mean, D mean, you should give a D. While you are adding the, without adding the catalyst, when you add the catalyst here, after adding the catalyst, the nature of the product should not be changed. The nature of the product should not be changed. Sir, what is the use, sir? What is the role of catalyst here? The catalyst, it can enhance or retard the rate of the reaction only. It should not affect the nature of the product. What should happen? D should be formed. Here also D is formed. In both cases, D is formed. No worry. So the product undisturbed. The product is formed. But what is there? The range of the product, the time range it can enhance. That is the role of catalyst. It should not change the, instead of the D, it should not give the E. Only D should come. Whether you are adding catalyst or not adding the catalyst, the product should not change. Likewise, the catalyst, some catalyst, when you have that problem will arise is when the chemical composition of catalyst is changed, then it will affect in the formation of product. It may affect the formation of product. So that only already we have seen it's the chemical composition should not change for the catalyst. Likewise, in the nature of the product should not be changed. Then, if you are taking solid catalyst, it should be finely divided. So, for example, nickel or you are taking something. If it make it in the finely small pieces, powdered form, then the action will be more. If solid catalyst is used, then it should be finely divided into pieces, small pieces. Then only why sir, what happening when you make it into very small pieces, the active center is more. According to surface chemistry, the active center is very important. So more active center, more reactions possible. Okay. For example, if I simply say, if you take a tablet, suddenly you swallow it, it will lately only dissolve into that, then it will be affected. Then that's why we for the children's, what we are doing, we are crushing into the powder the tablet. It's the same tablet, same amount, half or full. The tablet you are taking, crushed into powder. If you make it into powder, more surface area will be there, that the active center increases. Likewise, catalyst also, if you take a solid catalyst, whenever you take solid catalyst, it will be finely divided into powder. These are some properties. Okay. Then, so what are the characteristic of a catalyst we are saying? It is a small quantity. The quantity should be very small. Okay, not large amount. There should not be any chemical changes. Then a specific unit action, particular catalyst for particular reaction. It does not disturb the equilibrium. Equilibrium should not be disturbed. Then optimum temperature should be maintained. For optimum temperature only the catalyst will give a best quality. Okay. Well, simply if you add a catalyst you cannot get a best yield. That particular range of temperature should be maintained. That range where you get more yield, that temperature is called optimum temperature for the catalyst. Then it does not affect or changes the nature of the product. If A and B are giving the D, mean D should giving. Whether you are adding a catalyst or not adding the catalyst, it's not at all worry. The D should be formed. Nature of the D should not be changed. So there is a quality of it. When you take a solid catalyst, if you take a solid catalyst, finely divided into powdered, the crushed catalyst should be used in order to get a more yield. These are the few properties of the catalyst. Okay. Then let us move on to some other part of the catalysis. One is a promoter. Promoters. What is called a promoters? First of all, the promoter does not affect the reaction. First of all, it enhances the activity of catalyst. That is called promoter. It promoting the activity of catalyst. For example, if you take a Haber process, synthesis of ammonia, nitrogen and hydrogen in the catalyst Fe, ion catalyst, you are getting ammonia. Okay. Optimum temperature pressure should be maintained, you are getting the ammonia. Synthesis of ammonia is okay. But if you add a molybdenum, little bit of molybdenum to that, it will enhance the activity of ion. Okay. What is the role of ion? Ion is a catalyst. What is the catalyst? Which can alter the rate of the reaction. Here, when you simply add a nitrogen and hydrogen, you are getting ammonia very less. When you add, but ammonia will be forming, there is no worry at all. When simply adding nitrogen and hydrogen, you are getting ammonia, no worry. If you add iron, it will be more amount of ammonia because it's altered the rate of the reaction. Then it is too much faster. Since the activity of catalyst, you are getting more amount of ammonia. This is a role of catalyst. Sir, what happened to when you add a molybdenum? Like if you add a molybdenum, it is directly it does not involve into the reaction, but indirectly it enhances the activity of the catalyst. So promoter is a substance which enhances the activity of catalyst, not enhance the rate of the reaction. It is enhance the activity of the catalyst. By enhancing the activity of the catalyst can more active to get a more yield. So the promoter here, molybdenum is a promoter. whereas this one, iron is a catalyst, these two are reactant, ammonia is a product. Now it's clear what is called promoter, which promotes the activity of catalyst. Simple thing, not memorize. Which enhance the or which promotes the activity of catalyst, that is called a promoter. For example, in the Haber process of ammonia, iron is a catalyst. While using iron, you add a little bit of molybdenum to that, the process will be more fast. How the process directly not involving, it is not a role of catalyst here. Here it is doing some work with iron. By doing some work, that iron activity of iron will be more and more. That is enriched activity. So the activity of iron is enhanced. Then automatically you will get a more product. So promoter is a substance which enhance the activity of catalyst. Okay. Then when positive thing is there, then there will be a negative. That is called a catalytic poison. Catalytic poison. Okay, from the word itself we can come to the conclusion that poison, the activity of catalyst is poisoned by something. So something which poison the activity of catalyst, that is called catalytic poison, or which retard the activity of catalyst. Clear with this? Which retard the activity of catalyst, not overall reaction. Which retard the activity of catalyst, that is called a catalytic poison. For example, same if you take a nitrogen and hydrogen to give a Fe, to give a ammonia. In this case, if you add a H2S is a catalytic poison for the Haber process. If you add a molybdenum, the activity of iron will be enriched. If you add a H2S, the activity of iron will be retarded or reduced. So the activity is poisoned by H2S. Activity of catalyst poisoned by H2S. Automatically you will get the more yield will not be formed because the iron activity of iron is poisoned by the H2S. Likewise, we can have for a sulfur dioxide preparation, catalyst platinum, we can use the platinum catalyst. AS2, this is a catalytic poison which retard the activity of catalyst to disturb the yield. Okay, so the catalytic poison, it is involving in the catalyst. The activity of catalyst is reduced by the catalytic poison. So the then till more example you want, let me write H2 plus O2, 2H2O. If it is not balanced, you balance it first. Okay, then H2O formation. Here carbon monoxide is act as a catalytic poison. Carbon monoxide, it is here also platinum is catalyst. Carbon monoxide is disturbing the or poisoning the activity of the catalyst platinum. This is called a catalytic poison. Then let us move on to the autocatalyst. 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 The process is called autocatalysis. What is called autocatalyst? For example, if you take a ester hydrolysis without adding some catalyst, you may get, if the hydrolysis will happen, you are getting the acid and the alcohol. Okay. The reaction is very slow at first. Okay, the reaction is very slow at first because we are not adding catalyst. But after sometimes, after few minutes or few hours, the reaction will be too much faster. Then scientists, what is inquired there, then found out that automatically after sometimes one of the product formed is act as a catalyst. That is called autocatalyst. We are not separately adding some catalyst to that process. Even when a product is formed, automatically one of the product act as a catalyst. Then the reaction is too much faster. So when the reaction in which one of the product is act as a catalyst, that reactions are called autocatalyst. They themselves generate the catalyst. After generating the catalyst, that enhance the more yield. So in this process, acetic acid is act as a catalyst. Acetic acid is act as a autocatalyst. Likewise, you can have a arsenic hydrate. There, this is a decomposition of arsenic hydrate. You are getting a 2As plus 3H2O. Here, arsenic is act as an autocatalyst in this process. Dissociation will be very slow at first. After some times, you will have a more number of yield, because when the arsenic hydrate is dissociated into arsenic, AS also act as a catalyst, then the reaction will be passed. This is called the autocatalyst. At last, we are going to see about the negative catalyst. Negative catalysis or a negative catalyst. So simply if you are adding catalyst, the reaction is enhanced, that is called positive catalyst. At first we have seen so many examples, they are come under the positive catalyst. When you add something, they are enhancing the process. They are called a positive catalyst. Here you will have some substance which retards the rate of the reaction, which decreases the rate of the reaction. The substance which retard or decrease the rate of the reaction is called a negative catalyst. The process is called a negative catalysis. Okay. So you may have some confusion with the negative catalyst and a catalytic poison. Negative catalyst and catalytic poison both are very, very different. See, catalytic poison which decreases the activity of catalyst, not the reaction, which decreases the activity of catalyst, that is called catalytic poison. Whereas negative catalyst which retard the rate of the reaction, it is directly involved with the rate of the reaction. For example, the chloroform carbonyl chloride plus water. So here if you put a 4, then we are right. Okay. The negative catalyst here, see, ethanol is act as a negative catalyst. So ethanol is act as a negative catalyst. In chloroform, oxidates to give a carbonyl chloride in water. What happens? The reaction is simply, if you take the reaction when a chloroform oxygen, it will be going very well. When you add ethanol to it, see, in all reaction we may not enhance the rate of reaction. In some process, we need to slow down the rate of reaction. For that purpose, we need some catalyst. Those catalysts are called negative catalyst. Those processes called negative catalysis. This is ethanol is act as a negative catalyst here. Then if we take a decomposition of peroxide in the presence of platinum, okay, if it is not balanced, if you put 2 here, everything will be balanced. Okay. This is a platinum is a catalyst. If you put a platinum, this is positive catalysis. In same process, instead of platinum, if you add a glycerol, this alcohol or dilute acids. If you put a platinum, that is a positive catalysis. That is, platinum is a positive catalyst. It more dissociation, decomposition of hydrogen peroxide will happen. When if you add a glycerol or a dilute acids, the same process. Instead of platinum, if you use this glycerol or dilute acid, the rate of the reaction is retarded. Okay, or the rate very slow process. Okay, so which retard the rate of the reaction? The substance which retard the rate of the reaction, this is called a negative catalyst. The process is called negative catalysis. Okay, let me summarize all those which we are have seen today. Catalysis, the process where the catalyst is used, that process is called catalysis. What is catalyst? The small amount of substance which is alter the rate of the reaction is called catalyst. Then we have a different types of catalysis process. It all are same phases, reactant, product, catalyst, all are in the same state. Then they are called as a homogeneous catalysis. If anyone is differed there, then it is called heterogeneous catalysis. Then what are the characteristics of catalyst? We have seen listed out the characteristics of catalyst. Then let us, already we have seen that negative catalyst. At last, this is, if you add, the rate is enhance, that is called a positive catalyst. When you add some amount of substance, that is retard the rate of reaction, that is called negative catalyst. And the substance is called negative catalyst. The process is called a negative catalysis. Likewise, you have autocatalyst. Autocatalyst in few reactions, the one of the product formed is act as a catalyst. We need not add a separate catalyst to that. One of the product formed is act as a catalyst, that is called autocatalyst. Likewise, we have seen what are the promoters, what are the catalytic poison. See, promoter is a substance which enhance the activity, promote the activity of catalyst. Okay, they are called promoters. Likewise, we have a catalytic poison. What is called catalytic poison? Which retard or decreases the activity of catalyst. That is called catalytic poison. Likewise, we have seen a different type of catalysis process. There is one more catalysis process is there that is not given in your book. That is the induced catalyst. Induced catalyst means if there is one reaction is carried out, the another reaction parallelly due to the induced of those reaction it happened. For example, if we see, I am asking you to study. Well, you are not at all are acting as a studying persons. After sometimes you will be cheating me or you are not reading the book properly. That time in the same benches or nearby you, someone read properly well. After seeing him, you also induced to read or induced to study. That is called induced reaction. Because of someone they are doing, we also we can do. See, for we can physical example, we can say more. If someone running, we also attempt to run. Someone watch the movie, whether we are interested or not, we also start to watch the movie. Okay, for sometimes. Likewise, there are some chemical reaction, something happen parallelly, this also will happen. This is called induced reaction, induced catalyst. Some reaction is carried out, there will be induced reactions also. That is called induced catalyst. That is not given in your book. Only not bother about this. Whatever given in your book, you go through with this. There is autocatalyst, negative catalyst, positive catalyst, promoters, catalytic poison, everything. The characteristic of catalyst you have listed out. You read once again, you will be a bit clear. Thank you.